back in December in Norway last year, I actually had one guy coming from Beijing in China all the way to Trondheim in Norway to participate at PasswordsCon for 3 days, and then he went back to Beijing in China. So, you know, I mean...
Short trip.
Yeah, short trip, yeah. Las Vegas isn't that big. Yeah. Okay, so give it up for Devin.
Thanks, Per and organizers, for having me here today. The title of my talk, as you can see, is Poppin' Digital Locks. So today, what am I talking about? Today I'm talking about bypassing digital locks. I'm going to discuss kind of a retrospective of digital locks to get us in the kind of the frame or the mind frame of what we're talking about. I'm going to talk about physical systems that have digital locks. I'm going to talk about web systems that have digital locks. And then I'm going to move on to smartphone systems. That's what I'm attacking today. So who is this guy? Thanks for the introduction, Per. My name is Devin Egan. I'm the co-founder and CTO of LaunchKey. LaunchKey is a local startup here in Las Vegas involved with the downtown project. I'd be happy to answer any questions about that. Vegas Tech as well, if anyone has any questions about that. LaunchKey is a platform for allowing users to log in with their phones. It's the easiest way to say it. I've been a speaker in the past, DEF CON, BlueCon, WordCamp. I'm happy to be here as well. So a little bit of background about my talk. Where did the talk come from? Why am I talking about it? Why do I know about this stuff? Really, it comes from our bug bounty and our bug bounty system. For those who aren't familiar, a lot of companies, specifically security companies, encourage researchers to give us data, give us information. So what I'm presenting here today, some of these attacks are attacks that came to us through the bug bounty that we weren't aware of until we saw them ourselves. And I'm here to basically share them with you as well. That said, just a shout out to the researchers who did kind of lead us to some of these issues. Satish B has a great book out there. If this kind of a forensic analysis or pen testing is interesting to you, breaking smartphone stuff, I really recommend checking out his book. It's not my book. I don't make anything from it. I just recommend it because he's a smart guy. He's done bad things to our software. Andrew Smith, I think here as well. He's a LaunchKey engineer. He helped me with, and he performed a lot of the auditing performed for this talk, and where I pull some numbers from, he helped with that. So thank you, Andrew. You did a great job. So digital locks, again, to start off a retrospective. I'm going to start talking about where we were at, what lock systems we're familiar with, some systems that we're familiar with, and then get into attacking the smartphone locks and then defending them as well. So we're familiar with some physical systems and digital physical systems, digital safes, car doors, alarm systems, ATMs. What are some of the attacks that we're already used to for these physical systems? We see MacGyver attack. This might be aging me a little bit. MacGyver attack. MacGyver literally shaved off some graphite from a pencil, blew it onto a digital safe, and saw which numbers were hit a lot, and then it reduced the amount of entries that he had to do. ATMs, physical systems we've seen jackpotted. Barnaby Jack, RIP, did some amazing stuff bypassing digital locks, ATMs, just to have spit money out. We see default pins and passwords all the time on these systems as well. So they can be attacked that way. And finally, I don't know if you guys were paying attention last week, Brinks has a super secure safe that's up in the top left here that we bypass when you literally put a USB stick in that emulates a mouse and keyboard. So these systems are still being attacked today. Web systems. Again, this is a retrospective. A lot of this should be familiar to you guys. Password and PIN forms are digital, like I consider are digital locks. The way that we've seen them attacked in the past is through SQLI. You see a password or PIN field. You enter a nice little, SQLI statement. This has been closed in recent years, but still exists to some extent. XSS is another threat to web forms and web attacks. This will come up again a little bit, especially the man in the middle. Man in the middle attacks where someone's actively sniffing you, looking for passwords, etc. These are the attacks that we've seen in the past, which leads us to phone locks and digital locks. And what I'm going to be talking about today, I'm talking about Poppin smartphone locks. Really, again, I wanted to kind of get a retrospective of where we were at, what kind of systems we've seen, and these new systems, what kind of attacks we're seeing against them, and kind of what's going on. So for the setup, this might disappoint a lot of people. A lot of these attacks that I am performing that I'll be talking about are on a jailbroken iPhone. So just to be clear, this isn't a non-jailbroken iPhone that I'll be doing some of these attacks against. It is a jailbroken iPhone. I'll kind of get to why I still think it's important to secure data, mostly because it can be done and secure against these attacks. So 30 plus apps were audited. We did when we found something, we did disclose it to the companies that we found issues in. And much like people reported to our bug bounty, we also wanted to share, hey, you got the problems, here's maybe how to fix it. That for people that don't have bug bounties, that can go two ways. We get people angry at us and people who are clueless. So, but anyway, just a heads up if you start submitting full disclosure to people who aren't asking for it, they might get a little angry as well. With that said, 66% of the apps that we checked, this is password managers, this is authenticators, this is digital vaults, secret apps. Any app that has a PIN interface, we try to find and we try to attack just to kind of see. Again, not only for really the benefit is to figure out how to fix the problem. So the reason that we were doing this, the reason that we were interested in it, is so that we could, again, protect our own app.
Is that on those 66% of apps? Was that on non-jailbroken or jailbroken iPhones?
So again, this is jailbroken. These are jailbreak attacks, specifically the jailbroken attacks. So the tools that we use to test these. You're familiar with the Cycrypt. It's written by the same guy as the Sadia jailbreak website or jailbreak store. That's one of the tools that we talked about today. Keydump is exactly what it sounds like. If you're familiar with the keychain in the iOS world, it literally just dumps out the keychain data in raw text, and we'll see what that looks like. Snoopit is essentially a graphical user interface Cycrypt. So it's only caveat. It only runs on iOS 7 on 32-bit architecture, but it's like a click. It's like a Cycrypt that you can just click around. And then I'm also going to be talking quick about man-in-the-middle proxy, and that's where we'll see a similar attack that we see on the web already. So what's the first thing we do if we're going after one of these digital interfaces? We attack the views themselves. And if you're familiar with smartphone development, you have a view, and then you populate that view with the content that you're displaying. So how do you attack these views? Really, what you're going to be doing is you're going to be using a tool like Cycrypt. An attacker can dump all the view names and then guess or attempt to just miss these views. So the end result is that the PIN simply goes away. And what does this look like? A quick demo here. Dismissing the view. Say we found a method that we want to try, key unlock screen. Just for an example, our app isn't susceptible to this, but I didn't want to show someone else's app. This is the launch key app. A user is trying to attack this, and what I mean by attacking the view is usually what's happening when people write these is that the view is the only thing between the user and the application. You drop that view, and many times you're right in the application. The scariest places I've seen this are honestly password managers. Sometimes you can just drop them and be right in. It's really scary. So again, to dismiss this view, I'll kind of show this real quick. That's all up there. I don't know if you can read that, but it's Cycrypt. Essentially, I'm locating the view that I want to dismiss. In this case, is this interface. I'm putting that view information set of a variable p, and I'm simply running. In this case, it's p out play outro. It could be p unlock screen, and this is the Cycrypt tool. As soon as I want to basically drop that view, all I have to do is simply call that view, just play outro, and that's what it looks like. Again, this is just an image. I have videos that I can show you, but I didn't want to show you someone else's dropping. But that's what it looks like. Literally, you run that, it goes away, and then everything is in the whole app is right there for you to do whatever you want with. It's a pretty major one, and it's something that the first time I saw, I was like, just shocked. I had no idea that this was possible. Again, to back up, these are jailbroken. Broken phones that we're attacking, jailbroken views. The reason I think it's important to protect is that you don't know if there's going to be a 0 day that does jailbreak, every once in a while in the world. 950 million Androids last week were vulnerable. So again, I do think these are important things to protect against, especially since we can. Some of it is laziness or not even just knowing, like for us, we didn't even know that this existed. So after you've attacked the views, you can also attack the methods. Views, many times, there's calling methods, calling code in the background. So you can look for authenticate, login, set pin, update pin. You can call the view, you can call the method that the view itself is calling and simply dismiss the view again. Or you can do some other nasty things with attacking the methods directly. So attacking the code directly. You can set the pin. This is the #1 thing, kind of the easiest way to do it. If you're attacking and trying to get into an interface like this, one of these digital locks, you can simply maybe set the pin itself. So look through those methods. If you see something like set pin, you can attack that directly. You set the pin, tell it 1111. You go back to that interface, type 1111. The view drops, just like dismissing. Another way you can attack methods that you're detecting is to reset the counter. So what I mean by this is many of these locks, including usually at OS level, they have a common mechanism to lock you out after X amount of attempts. Very common. What's scary about this is that if someone is trying to brute force it, if they can access it in this way, they can simply reset the counter or set the counter to whatever, or there might be a method, for instance, to set the counter to whatever they want. I haven't done 9, I only got 1 left. Now I have 0, and I can start all over again. So you can see this is another pretty scary one. Again, this isn't as effective as just dropping the view, setting the pin. Brute forcing, especially in this case, would probably be manual and be pretty brutal, but it gives them a lot more chances to get in. Dump/set the pin in storage. So this is another scary one, and this is kind of the one that I really wanted to draw attention to, because in the web world, if you don't hash your password, it's like sacrilege. And for some reason, because of this keychain thing, everyone is so confident that almost no one, I'd say 80%, I think was the number, of people who put data in keychain don't even attempt to hash stuff that should be hashed. I'll get to that in a second, but it just seems like this common thing that we've been doing for years. Use a strong algorithm, hash your stuff. People don't do it. You see this all the time. There's the pin 1, 2, 3, 4. So key dump on a jailbroken iOS lets you do some really nasty things. Literally just dump your whole keychain data. And there's a lot in there. It's really scary. A new tool came out in the last couple of weeks that it didn't have a lot of time to play with, but it actually allows you to edit the keychain. So much like setting the pin you could before, if it's expecting plain text, you can edit the keychain and set the pin right there directly in the keychain as well. I'm talking a lot about iOS and keychain, but this is where it also comes into Android. Android doesn't have a keychain. A lot of times it relies on user permissions, storing data within a file, for instance, or inside of like an SQLite file. And they're banking on the permissions, again, of Android to save them. Again, we saw a nasty leak last week that could do remote code execution, but it could also say, oh, hey, I know this password manager doesn't hash their data. Let's ship all that back to me as well. So again, this is an attack. This is nasty. Like wherever you're storing your data, let's at least remember to hash stuff that's important. And then finally, the other way that I've really seen these attacks performed is by man-in-the-middle. And this might sound familiar. That's because a lot of these digital locks are literally just web forms that are submitting to a web page. Many rely on SSL for this point, but a lot of them don't verify that endpoint. And I'll talk about that when we start talking about defense, how to defend against these things. There are ways to verify that, especially on the mobile platform. It's really cool that your app can say, am I talking to my API? And you can be pretty confident that you are not, or you can kill the network connection. So part 3, defense and lessons. And this is where I'm going to talk individually, kind of how do we prevent, if you're a developer, especially responsible for one of these locks, how do you prevent this? What do we do? What are the defenses? And what are the lessons learned for the future? So the first one is to protect the views and methods. Kind of a no-duh. Just basically making it so it's impossible or a lot harder to just simply dismiss the view because it's very simple to do. Tokens and or nonces can be added to those methods and views. It could be a hard-coded, crazy number that your code calls. It's just one more piece of information that has to be passed along. So it's not simply play outro. It has to be play outro with variable. Does that make sense? You can hide the view altogether. There's hidden flags in iOS, and you can hide the view and all the view controllers inside the apps folder. Again, this might make sense only to iOS developers. And finally, you can obfuscate the manifest files and obfuscate the functions themselves. So don't make it really easy for someone to say, oh, log in, and make it really obvious what those functions are. The next thing you can do is don't roll your own pin lock. There are third-party libraries out there that we've tested. Some that are good, some that are terrible. That all these attacks are applicable against. At an OS level, things like Touch ID, things like Samsung fingerprint SDKs. I know some people are aware of the biometrics. That not all phones have this hardware, but really you can rely. You can trust these a lot more, those native OS integrations, than maybe yourself. Again, these are tied so low level. I haven't seen attacks against Touch ID and Samsung fingerprint, for instance. But if anyone has, please let me know. Another thing you can do, if you're really worried about this stuff, is just jailbreak. It's classic jailbreak detection. If you're saying, okay, I'll just shut down the whole thing as soon as someone starts this up, and I won't worry about any of this stuff. Developers can put jailbreak detection there. For users, I would stop jailbreaking your device. An informal poll at LaunchKey, I think 50% of us in the office have jailbroken devices, and that was kind of an eye-opener. It's a lot of people still jailbreak their device, and honestly, it's not recommended. But anyways, developers, if you want to shut down the ability for someone to potentially hack your app, you can also add jailbreak detection to it. This is one of my favorites, a honeypot method review. So if an attacker has access to the jailbroken app, is attacking it, you can add some really maybe fat methods or views in there, like authorize all the things, or give me all the passwords. Something really attractive to a hacker. And then when they invoke that function, a function that would never be called by your software, you can do a couple of things. A, you can report it back to you. You can say, hey, this IP is doing some really terrible things, like a true honeypot. You can get alerted. You can even feed it into a system like NightGen, etc. Or you can do like what LaunchKey does. You can literally destroy that device data. So you can say, oh, someone's doing something really bad. We've detected an attack. Unpair that data or delete all my data because I know something very bad is happening. That's another way. Again, I really like that one because it's kind of an offensive attack. It's your only chance if someone's really poking around your app and doing really bad things to it. Utilize the PIN for encryption. So this PIN or passphrase, whatever the knowledge factor is that you're getting from the user, use it to then encrypt all the data that your app's going to use. Does that make sense? So it is the key to the rest of your data. This is twofold, really cool, because it turns your knowledge factor into a symmetric key. It doesn't store the key even in a hash, in any way. It's only used to unlock the data that your app's using. So again, that's a really cool one and a really cool way to use the PIN. So rather than putting it plain text into keychain, use the key, use that PIN as a symmetric key. So for instance, AES, use that as the AES key. Data protection. Don't get lazy. I kind of just started in this a few minutes ago, but it seems so easy to lean on keychain or these permissions. And I know we're all developing stuff very, very quickly, but hash the appropriate data. Even if this is a jailbroken device, would you rather see 1, 2, 3, 4, or would you rather see a hash in there? I mean, all day long, this at least protects the password or that knowledge factor in some way. Again, with the keychain dump now, or the keychain editor, it's kind of scary. If they can guess your hashing algorithm, they can potentially still just inject whatever password they want and get in there anyway. So that's maybe why something like utilizing the PIN for encryption works really, really well. So data protection, again, don't get lazy. Hash the appropriate data. For smartphones, This usually means my recommendation is PBKDF2. It's one of the key derivation functions that probably, if you've ever hashed a password, you're familiar with. All smartphones, it's iOS, Android, and anyone know what WP is? Windows Phone? Windows Phone, they all support this, this function. By the way, iOS is really fast at PBKDF2, I assume because of the hardware internally, and Android is really slow. Just a heads up if you start implementing this. And then finally, SSL pinning and man-in-the-middle defense. So again, for those web views that I was talking about, a very common way to attack those web views is if you're on a public Wi-Fi network, say a conference, and you're sending data via a mobile app to an API endpoint, for instance, to authenticate you. There's a method called SSL pinning that, for instance, AF networking and iOS supports. Android supports this. That uses the public key of your SSL cert to guarantee that you're talking to that server. So a lot of times when I don't see this implemented, what I do see is people sending, it's just, again, just trusting the SSL, sending the data straight over. If you're man-in-the-middling that data, via man-in-the-middle proxy or something else nefarious, you could, decrypt, basically, setting up a middle SSL CA and getting all their stuff. You'll be able to see everything. If you do that with SSL pinning enabled, it stops that connection. So again, the user won't have their password or their PIN stolen. Another thing I've seen, if you're not using SSL PIN or you can't for some reason, you can pre-hash or encrypt the data before you even send it. So again, I know SSL is this end-all be-all. Everyone's like, you do SSL, you're fine. Again, in the mobile world or in public networks, your traffic, even at your work, your traffic, all your traffic might be decrypted. So again, as app developers or people protecting these digital locks, pre-hash on the phone itself and then send it along. Not only does it save you computing power if you're a big shop worried about milliseconds, you can save yourself some computing power because you don't have to compute that hash on your side. And again, it basically protects it in transit outside of SSL. It's kind of a defense in depth again. Like don't just rely on the SSL. Don't just rely on keychain. If you can hash the data, why not? It adds that extra layer of protection. Makes it a lot harder to attack. So with that said, kind of the lessons of the past we see kind of applied to now. With a few things like the web forms still kind of exist inside of these smartphones apps. And I think these new kind of digital locks are with us to stay. Let's make sure we're implementing them well. Let's make sure we're securing them well. And that's all I got today. So. Thanks for your time. If you have any questions, I'll be here afterwards. If you have any questions about Vegas or anything else, I'm available.
Questions? Yeah. Got 3 minutes.
Okay, let me try to go. These are my questions. How reliable is jailbreak detection?
So he asked, how reliable is jailbreak detection? I think that's debatable how reliable that is. But everything I've seen, it's good, but never guaranteed. So like everything, there's multiple ways to do it, multiple ways to actually detect that. And obviously, the more different systems and the more different ways you're looking at, the different ways you're looking at it, you can do it. But the long story short, it's not 100% for sure. Any other questions?
Jeff.
Oh,
Okay.
you got one right there?
Yeah. Okay.
Yeah.
Got in Touch ID. This is more of a comment. Touch ID, the use of local authentication framework to do it, that's much better than anything else. If you just do local authentication, it's like groups or just about classes.
Yeah, exactly. And I didn't attack that directly, but and we haven't been able to. But I'd like to talk more about that as well.
Yeah, it's been done.
Yeah.
There's a jailbreak attack for those people who use workaround-based Microsoft password.
Yeah.
If you choose to use Touch ID, it stores the master password with it.
Somewhere,
in the
yeah.
somewhere in the eye of a computer, so it's outside of our own encryption, then yes, there are hacks that can jailbreak hacks that can pass local off, and then they've got to work on trying to de-obfuscate what.
Yeah,
But tell me,
I certainly believe it's
so
possible.
it's
My only recommendation for saying using it is at least all these other things that they won't be able to worry about. Again, in the jailbreak world, it really is kind of scary. But really what I think, again, what I was talking about and what I'm trying to get across is that we don't know if there will be a jailbreak exploit for the phone, that something really bad could happen. So if you're app developers, if you're responsible for apps, please add these protections. Really, again, it really helps a lot. You don't know if one of your users will be jailbroken because, again, a lot of people jailbreak their phones.
Okay, so yeah, we're breaking it off. So thank you again, Devin.
Thank you very much.
Yeah.